Good afternoon, everyone. Hopefully, I'm audible. Um, this is Sirisha, and I'm from CLISO. I'm a Ceph engineer working on different projects in Ceph and dealing with so many clusters that customers operate. So, I'm here to talk about data migration. Interesting topics. We have many stories around data migration, so many painful stories probably, and some happy stories too. So, and also I would like to introduce our chorus tool, the synchronization tool that we have developed in-house to deal with data migration um, and also a powerful S3 browser which caters to seeing your data, the S3 browser, and all the other topics here. We always wonder, why do we want to migrate the data at all? So there can be several scenarios where we end up migrating data from one cluster to the other. So we are talking about some private cloud Ceph clusters, and there is powerful hardware backing those Ceph clusters. Obviously, the hardware will traverse through a life cycle and it will eventually fall at the end of life, and that might trigger for us to augment the existing Ceph clusters with the new hardware with a specific SKU, or if that is not possible, and it might not be possible always, so we'll end up building new Ceph clusters, and we'll start using that as our production cluster, and then the existing data which is in our old private cloud, we'll have to migrate that and we'll have to copy that onto the new cloud and start operating from there. That can be one of the reasons. And obviously, if we are planning for new clusters in our environment, then we also end up migrating some parts of the data. Data migration is definitely a Herculean task. We at CLISO migrate a lot of infrastructure. We migrate a lot of data for different customers, and that is mostly S3 based storage. And obviously, we have seen so many challenges with data migration because we operate migrating petabytes of storage. All the customers clusters have petabytes of storage, and the challenge with copying petabytes across clusters is definitely great. There's a huge challenge, I would say. And then comes the continuous monitoring and time consumed. So when we talk about copying petabytes across different clusters, it definitely is a huge time consuming thing because it takes weeks and even months based on the infrastructure that we have and where the migration is actually running. And the time obviously is too huge, right? And the tools that are used for migration. So we use some very reliable tools like rclone for data migration, and that itself has so many features. But then sometimes the infrastructure where the rclone is running for migration, be it the powerful virtual machines, good network, but sometimes there is a stopgap, like if the VM goes down, and there's a lot of challenge around where the rclone is running also. So rclone is also intelligent enough to restart the job based on the E tag and a lot of other parameters for the data. But then we cannot always guarantee that the migration is smooth. Obviously, when we talk about migrating the data, we do not completely shut down the existing cluster. We always have writes and different update operations happening on the existing data, and that makes the migration even more difficult. Let me share some of our experiences where we had a customer for whom we had to migrate petabytes of storage from their existing cluster to the new cluster that we have built for them. So as it is, their existing Ceph cluster was end of life, so we built a new cluster for them from the scratch, and then we had to migrate around 3 petabytes or more of data from the between the two clusters, and there was a scenario where there was one bucket that hosted more than 100 million objects, and the size of the bucket was itself 100 TB. So monitoring the migration or copying of that bucket alone was a huge task. We initially used rclone as our data migration tool, and all the bucket and the objects did contain metadata. There were ACLs on the existing buckets in the existing old cluster. So initially we had to make sure that the user accounts were copied, and the ACLs of the object along with the data have to be copied too. So we made sure that the entire migration happened in phases. So again, as I told, due to the challenges that we faced in the migration process, we ended up in having our own learnings, and that led to the development of a tool called Chorus, which is a synchronization tool, the data replication software. So the interesting fact here is, like, there can be n number of storage backends, and then you can operate all the storage backends with one tool called Chorus. And if I have to specify, now the capability is for S3 based storage backends, be it of different vendors and in different regions. Chorus is capable of operating all the storage backends. The initial problem statement that we had in front of us was to migrate different S3 vendor data with reduced downtime. So as it is, different tools have different capabilities of migrating, and then we should assure that the downtime is as minimum as possible, and we should make sure that the data is consistent and migrated completely. And the second thing is how to back up S3 data to another S3 in different region and different vendors. So as I already told, it is agnostic, it is vendor agnostic. It can talk to any storage backend which is S3 based. So the initial goals were to have a vendor agnostic solution fast, which include a pluggable architecture. Like every component is loosely coupled. Like you can replace it anytime. There was enough benchmarking done, and also with all the learnings, the right components and right tools were used for this chorus, and the focus on correctness. So when we are copying data across storage backends, all we want is the data to be consistent across the storage backends. So the focus was mostly on the correctness, and the acknowledgement that is received and everything is properly configured. So migrating big bucket under the load with reduced downtime. Now in our previous example, I did talk about a bucket hosting 100 million objects, and which is of size 100 TB approximately. So that huge bucket has to be migrated and with reduced downtime. So all of this were the focus for our tool. An overview of this tool basically is, of all the storage backends that we configure for Chorus, we have to have one main storage. We need to configure it prior, and the rest of the storage backends will all be the follower backends. So when we configure one main storage, the data between the storage backend, the main storage and the follower backends can be configured, and we can create tasks for the replication between the backends. And Chorus has an S3 API. So as mentioned earlier, each storage backend will have its own API, but the functionality here is, like, you need not interact with the storage backend's API, but you can interact with Chorus API directly and talk to different storage backends. So initially the requests are routed to the main storage, which we configure in the configuration, and then asynchronously the replication is done to the follower backends. So there is this, like, when we introduce Chorus into our ecosystem, obviously we'll have certain clusters which are already operating and which will have data. So all the existing data is replicated from main to the storage backend in the background, main to the follower backends in the background. So whenever we configure these backends, it makes sure that the existing data in the main storage is initially copied to the follower backends, and then we can also have a live replication and live migration going on along with this background replication. So the data replication can be configured, paused, resumed by the user. So we can configure a bucket level replication initially, and we can maintain the states of the replication, like we can pause it, we can resume it anytime we want. And also this all is we can consume this using a admin API or a CLI. So the features include routing and replication per bucket. So if my main storage has n number of buckets already, I can choose to copy which bucket across the follower backends also. And there is a bucket level replication. So how does it happen is, when all the configuration is done, and if I choose to copy one bucket, initially based on it lists the bucket first, and depends on how many objects are there in the bucket, so many tasks are created in the backend, and for each object there is a task, and eventually the object is copied with that task. That ensures that all the objects in the bucket are copied across the different backends. So there is a synchronization between object or bucket metadata, content tags, ACLs. All the metadata of the objects are taken care of and they are copied, and then this maintains consistency of the metadata between the backends as well. So as I already spoke, migrating existing data in the background, and we can always track the replication lag. We have a dashboard for the entire Chorus tool for us to visualize the replication status, like how fast is it, how slow is it, and how can we improve based on the configuration options. So Chorus also exposes Prometheus metrics. So the logs are in JSON, and the monitoring stack used is Loki and Grafana for us to visualize the replication status and the metrics. So briefly about the flow of Chorus. So initially, when the request comes, let me explain you various components here. So there is this Chorus proxy and Chorus worker. Chorus proxy receives the request, and Chorus worker is responsible to execute the to pick up the tasks from Redis, and also make sure that the replication is done according to the policies. So there are different policies. As mentioned, there is routing policy and replication policy. So initially, when a request comes to S3, the Chorus proxy, based on where the routing has to happen, it picks up the storage backend and it sends the request accordingly, and the request is sent back from the storage backend and is served. Coming to the replication policy, so that's the main routing policy where the data has to go in. And coming to the replication, so here when we configure that the initial routing has to go to min.io, and then the replication has to happen to Ceph in the backend. So the same request is based on the replication policy. It goes and creates a task in Redis, and the Chorus worker picks up the task, and the replication happens from min.io to Ceph. So this is briefly the flow. And Chorus worker, if you see, you can access Chorus worker using a web UI and a CLI. So the states are all communicated through gRPC. So we can see, we can pause, we can resume, we can create a new task based on what bucket we want to migrate. So the components of Chorus are all written in these languages. So proxy and worker are written in Go. Admin UI is in Vue.js and Redis, obviously. And all of the deployment of all these components are done in a containerized fashion on Kubernetes. Let us briefly talk about the operations in Chorus. What does Redis do? So, as discussed earlier, Redis is responsible for like creation of tasks and sending the worker picks up the tasks from Redis. So here the scaling for Redis happens using Redis cluster, and there is Redis append only file and Redis snapshot for persistence. And for tolerance, fault tolerance in case of Redis data loss, so the bucket replication can always be restarted. So as per our benchmarking, the memory consumption for around 1 million objects to be migrated is approximately around 105 MB. And if there are around 1 million tasks in the queue, the memory consumption would be around 700 MB. So the low CPU, the CPU consumption is quite low for Redis, and it is around 100 to 1000 requests per second. Coming to the proxy, this is kind of a very important component of the entire chorus, where it receives the requests for both replication and routing. So it is stateless, it has less memory consumption, it has less CPU consumption, but it needs a high network because of the requests. And coming to the worker component, this is again kind of a brain behind the replication. So it's again stateless, it consumes high memory and high network, but less CPU. So for the worker instance, network and memory consumption can be rate limited. So for example, if in our cluster we have multiple operations happening, like there are huge workloads going on, but we do not want this migration to be impacting our existing workloads. So we can always rate limit this at the worker config, and then we can take care of the replication at our own configuration parameters. So the current S3 API compatibility that we have for Chorus, there are various, we can perform bucket operations, all the basic bucket operations, bucket tagging and bucket ACLs. All these are addressed. And objects, similarly object operations, object multiparts, object ACL and object tagging. All of this are currently supported in the Chorus tool. What are the next steps? I would like to concentrate on the last two because bucket versioning and lifecycle policy are highly discussed. So this is very important. So we are working on that, and bucket versioning and lifecycle policy are our next steps. And Swift API compatibility, currently all we have, all the supported backends are all S3 based. Now we are trying to have Swift API compatibility as well. And then bucket notifications, event logs. So we need not, we can enable bucket notifications and event logs at the backend level for buckets, so that it's easy for us. Instead of querying the chorus every time, we can have those enabled for our bucket notifications to help us. And load balance read request for replicated data. For example, if we know that a particular bucket is copied between multiple backends, so we can always load balance these requests. Like we need not hit the primary storage always. We can load balance the read request to the other storage backends as well. So routing policy alternatives, like we are working on having a routing policy, like we can, if a request comes for storing a huge amount of, for a particular object size, we can route it to a certain backend, and similarly, various parameters will fall in place for this routing policy. So performing more load tests, because Now we are talking about a bucket of size 100 million, which hosts 100 million objects, and of size 100 TB. It can grow more in size. So, how effectively can we copy huge buckets under high loads, and also with reduced downtime? We are performing more load tests for the same, and obviously the API cost or resource optimization. So the active use cases in front of us are active transparent proxy post migration. So as of today, if we have configured one main storage and multiple follower storage backends, and we should be able to switch the proxy, and we should be able to configure the follower backend as a main storage backend as well once the migration activity is completed. And the second is the robust backup service. So these days we concentrate, of course, we concentrate more on high availability and also disaster recovery. So when we have one tool managing multiple storage backends, we can easily achieve backup as well. So when we have the migration completed, we can we can definitely switch between one backend to the other backend. If one backend goes down, obviously the other backend, while we know the entire status of migration, we should be able to talk to the other backend soon, and that acts as a backup service for us. Are there any questions before I show you some interesting videos on our demo? Okay. I hope it's legible. So this is our Chorus CLI. So here, if you see, this is all a dummy storage backends we have created. So this is the first storage, and this is the second storage, and that's the proxy URL. So this is the configuration of the first storage. All we want to show here is how we replicate data between two storages, and how the live replication also happens when we change any data in the main storage. So here we are trying to create a bucket in the first main storage. Here, if you see, in the configuration shows that the main storage is 1, which is first storage. And then there is a sync. Oh, of course, we have created a bucket, and we are syncing a folder to the backend, to the bucket. So if we see the list operation on the bucket, in the first storage, we are sure that the entire folder is copied. So this will not be there in the second storage, the backend storage or the follower backend, because it hasn't been replicated yet. So the CLI is named core CTL. So this is how you visualize the dashboard. And then when you start replicating, so that's the user you specify, and also the bucket name. So yeah, and the bucket name, and then this creates a task here, like user bucket, and from which backend to which backend is the copy happening. So initially in the backend, as I mentioned, the existing data is already copied to the follower backend. So yeah, that's the first storage, and in the second storage also the replication has happened already. So now we are trying to see what happens if we add new data to the existing bucket. How the replication happens behind the scenes. So since we already created a request for the replication to happen, whenever we modify the content of the existing bucket, so we see an event created, which is when you make that change in the first storage, an event is created, and that is replicated to the secondary storage. So as and when you modify the data, there are events created, and the replication happens behind the scenes. Yeah, this is just to verify that both the storage has the same data and it is consistent across the multiple storage backends. So now I'm going to show, similarly we have a UI. So we can configure, we can do all the operations that we have just shown using the CLI through the admin UI as well. So as you see, this is actually, that was a test data, but this is the actual live backend. So we see that there are 3 storages configured, and we can also visualize the uptime for proxy worker, and we can all see the storages replication and monitoring and everything happening on the web page. So this is the credentials. So initially, all the storage backends, we need to configure the credentials in the configuration file for the communication to happen. And we have multiple filters, and we can definitely see all the states of the replication. We can pause, we can resume, so we can maintain the states of the replication as well, and we can actually choose which bucket to copy as well. So we have the control at the bucket level, and all the objects within that bucket can be copied, and we can pause it anytime. Yeah, this demo is basically to show what all we can achieve through the web UI. Just speed up. Yeah. So we can see, okay, we can, if we see that we need to pause a particular application, we can do it, and we can see how many modifications have been done on that data after we have paused that replication. So this is an interesting web UI where we can manage a lot with the replication and the copying of data. So yeah. So you can pause, you can resume. So there is that we also have an S3 browser, which is very similar to which helps us manage all our S3 data. So we can do various operations like uploading a bucket, and all creating a bucket, uploading files, and lot of other bucket and object operations using the S3 browser. Oh, okay. Somehow the screen sharing got messed up. So the next slide was about the resources, like our blog posts and various documents about Chorus. So are there any questions around, and what do you feel about this? And you can definitely reach out to us and ask more questions if you have any. Thank you.